Hello students, welcome back. Let's solve the exercise question number 4 of chapter 12 electricity from class 10 NCERT science book. And the question goes like this. Two conducting wires of the same material and of equal length and equal diameter are first connected in series and then parallel in a circuit across the same potential difference. The ratio of heat produced in series and parallel combination would be, is it 1:2, is it 2:1, is it 1:4, or is it 4:1? So here we have been given two conducting wires of the same material and they are of equal length and equal diameter. These two wires are first connected in series and then in parallel across the same potential difference. That is, the potential difference remains the same, but first these two wires are connected in series and then they are connected in parallel. Now a certain amount of heat is produced when current is passed through this wire. So we have to find out the amount of heat produced when they are connected in series and then when they are connected in parallel. And after that we have to find out the ratio of the heat produced in these two cases. So let's solve it. Now the resistance of a conductor is given by the formula R is equal to rho L by A. Now in these two wires it is given that the material remains the same. That means for both the wires the rho value remains the same because the resistivity rho depends upon the nature of material. Now since the nature of material remains the same in both the wires, rho value will be the same. Now again, for both the wires the lengths are same and also the diameters are same, which means that they have the same area of cross section. So since all the values are same for both the wires, the resistance of these two wires will be the same. That is, the resistance of the first wire will be equal to the resistance of the second wire, whose value will be R. Now first these two wires are connected in series. So let's solve it for the series part first. Now these two wires are connected in series as we can see here. And first let's find out the equivalent resistance when these two wires are connected in series. Now for the series we know RS is R1 plus R2, which gives us R plus R, that is 2R. So the equivalent resistance when these two wires are connected in series is 2R. Now let's find out the equivalent resistance when these wires are connected in parallel. Now for a parallel combination, the equivalent resistance is given by the formula 1 by Rp is 1 by R1 plus 1 by R2, so which is 1 by R plus 1 by R because both the wires have the same resistance. So 1 by Rp comes to be 2 by R. Since 1 by Rp is 2 by R, so Rp will be R by 2. So this is the equivalent resistance when these wires are connected in parallel. Now it's given that both these wires are connected across the same potential difference. So we'll write here, let the potential difference is equal to V. Now the time for which current flows in both the wires is the same. So let's write down time taken is equal to T. That is the time for which the current flows in both the wires. Now we know the heat produced is given by H is equal to I square RT. Now from Ohm's law we know V is equal to IR. So I will be V by R. Now substituting this value of I in this equation, we get it is V by R whole square into R into T, which is V square by R square into R into T, which is V square T by R. So the heat is given by the formula V square T by R. Using this formula we will find out the heat produced when the wires are connected in series and then in parallel. Now using this formula let's find out the heat produced when the resistors are connected in series. So I write here heat produced when in series is equal to V square T by the resistance in series. Now the value of resistance in series is equal to 2R. So substituting the value of RS here, it's V square T by 2R. So this is the amount of heat produced when the resistors are connected in series. Now let's find out the heat produced when the resistors are connected in parallel. So it is HP is equal to V square T by RP, which is V square T by Rp value we got over here is R by 2. So it is R by 2. Now this 2 goes up, so it is HP is equal to 2V square T by R. So this is the value of heat produced when the resistors are connected in parallel. Now we have to find out the ratio of these two. So I write here HS by HP, that is the ratio of heat produced when the resistors are connected in series to the amount of heat produced when they are connected in parallel, is V square T by 2R divided by 2V square T by R. Now if you are finding it difficult to solve it this way, you can simply write V square T by 2R. This is divided by this value. So I write here divided by 2V square T by R, which is V square T by 2R multiplied by the reciprocal of this value, which is R by 2V square T. R cancels, V square T cancels, so it's 2 into 2, that is 4. So HS by HP is 1 by 4, or HS is to HP is 1 is to 4. So the ratio of heat produced when the resistors are connected in series to that when they are connected in parallel is 1 is to 4. So our option C will be the correct answer, that is the ratio of heat produced in series is to the heat produced in parallel is 1 is to 4. So this is the answer. I hope you have understood the solution to this question. If this video was helpful to you, please like this video, share it with your friends, and don't forget to subscribe to the channel. Thanks for watching. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.